Today we're going to be talking about continuous and discrete functions. We're going to start first with vocabulary. A continuous function is a graph that's connected. Or if you're looking at a word problem, it can contain any value. So it could contain fractions, decimals, whole numbers. On a graph, you actually have a line drawn or a curve drawn between points. A discrete function is a graph that is broken or a word problem that can contain specific values only. So for example, on a graph, it looks kind of like a scatter plot. It's just a whole bunch of individual points. And for a word problem, it can only contain specific like whole values. You can't have half of something or a fourth of something. Let's take a look at some word problems first, and we're just going to identify, are they examples of continuous or discrete, and how did we know? So number 1 says a store sells pizza by the slice. Each slice is $2.50. Is this continuous or discrete? The correct answer to this is discrete. And the reason being is if I'm going to buy a slice of pizza, the store is not going to let me buy half a slice. I can only purchase whole slices. Number 2, when making cheese, the weight of the cheese depends on the number of gallons of milk used. Each gallon of milk produces 3 pounds of cheese. This one is continuous. The reason I know that it's continuous is because I can use any amount of milk that I want. And number 3, when creating a class schedule, counselors can put a max of 30 students into a classroom. This one is going to be discrete, and the reason being is because you cannot have half a student. All right, now we're going to look at continuous versus discrete graphs. Remember, I told you continuous is connected, so the points would be connected by a line of some sort. Discrete would be broken, so the graph is just going to show points but no connection between the points. So looking at number 1, you can tell that this is a discrete graph because the points are not connected in any way. Is it a function? Remember, we're looking to see, are any points aligned vertically? And you can see on this particular graph, none of the points align vertically. So yes, it is a function because it passes the vertical line test. And I'm going to put VLT for short. All right, example number 2. Continuous or discrete. Again, you can tell that the points are not connected in any way, so that's going to be a discrete graph. Is it a function? Well, you can see right here that these 2 points align vertically, so the answer to that is no. It fails the vertical line test. Let's look at 2 more examples. Example number 3, continuous or discrete. Well, looking at this one, I can't even see the individual points that fall on the line because they're not visible. So that automatically tells me this is a continuous graph. Now, to tell whether it's a function or not, again, we can't see the individual points, but if you remember, there is a point at every spot along this line. And if you look at these, they're all aligned vertically. So the answer to that is no, it's not a function. It fails the vertical line test. And last example, number 4, continuous or discrete. Again, I see 2 points this time, but you can see that they're connected with that line. So because it's connected, it is a continuous graph. Is it a function or not? There are no points aligned vertically, so yes, it is a function. It passes the vertical line test, the VLT. All right, now that we have learned how to tell the difference between a continuous or discrete graph, we're going to focus on discrete graphs only, and we're going to determine how can I name the domain and range of a graph. So the first thing I'm going to do is name all of the ordered pairs that I see on the graph. So if I name this point, that is 1, 2, 3, that's -3, comma 3. This one would be -2, comma 2. We have 0, 0, 2, 0, and 1, 2, 3, 4, 4, comma -2. All right, once we have those, I can then look, I'm going to focus strictly on my x values because remember that's my domain. And I'm going to write those least to greatest in a set of brackets. So -3, then -2, 0, 2, 4. Close my bracket. For my range, I'm going to focus on just my y values. Remember, again, least to greatest, and you don't have to duplicate. So smallest one is -2, then I have a 0. I do not have to write the second 0, and then 2 and 3. Is this a function? None of them align vertically, but you can also tell by looking over here at these domain values, none of them repeat. So yes, it is a function. Why? Because it passes the vertical line test. Okay, let's look at example number 2. Again, I'm going to name all of the ordered pairs. Right here I have 1, 2, 3, 4. So I have -4, 1, 2, 3, 4, 4. Then I have -2, 3, -2, 1, 0, -2, 3, -3, and 5, -5. Again, my domain is going to be all my x values, least to greatest, not duplicating. So -4, -2, I don't need the other -2, 0, 3, and 5. Then for my range, I'm looking at my y values, least to greatest, that would be -5, -3, -2, 1, 3, and 4. Is this one a function? You can see these two align vertically, and you can see these two have a repeating x value where the y value is different. So the answer to that is no. And you can say either fails the vertical line test, or you can say that the x value of -2 repeats with a different y value. Let's look at our last two examples. Example 3, I'm going to name my ordered pairs. I have this one at -2, comma 1, 2, 3, 4, -2, 2, -2, 0, and -2, 1, 2, 3, 4, -4. So my domain, all my x values, least to greatest. Well, they're all the same, so I'm just going to put -2. For my range, remember it's all my y values, least to greatest, and I don't need to duplicate. So smallest was -4, 0, 2, 4. Close my bracket. Okay, on my graph, I can see that they all align vertically, and I can see on my points that they all have the same x value. So this is not a function, and it fails the vertical line test. And last example, I'm going to name my ordered pairs. First one I have is 1, 2, 3, 4, so -4, comma, -2. Then we have -2, comma, -2. And then we have 3, -2. Domain, I'm looking at all those x values, least to greatest. So -4, comma, -2, comma, 3. And for my range, I'm looking at those y values. All the y values are the same, so I'm just putting -2. Is it a function? I'm looking, none of them align vertically, and none of the x values are the same. Remember, I don't care about the y values. So this is a function, and you can say that there's no repeating x values, or you can say it passes the vertical line test.